In this video, I want to take a chance to go over a relatively complex example of a proof in natural deduction. So what I've laid out already here is the premises of the argument and the conclusion, and you might find that this is a useful format. So we don't have the argument laid out in its normal form. We've just started with the proof. But remember that the first statements of your proof will be your assumptions. So we have the premises as our assumptions. If A, then B, then C. If C and D, then E. If F, then not. If D, then E. From those premises, we're supposed to conclude if A, then if B, then not F. So remember that these three dots mean therefore, and you might find it useful to do what I've done here, which is leave your conclusion next to one of the premises to remind you what you're aiming for at the end of your proof. Then, just for details of structure, remember that you need the vertical line that spans the length of the proof, and you need a horizontal line that marks the end of your assumptions, and the start of the rules and the lines that follow from the rules in your proof. Now, how do you start at this point? The first thing that I would suggest doing is looking at your assumptions, your premises, seeing if there are any proof rules that you can apply that don't demand subproofs. So, for example, if it was possible to apply conditional elimination with the assumptions you have already, it would likely be beneficial for you to do so. You'll eventually see that you don't always need to apply all of the non-subproof rules immediately, or that you might not use all of the lines if you apply all those rules that you can. But if you at least have all of those potential ones laid out, then they're available for you within the subproofs. Why would you start with the non-subproof rules first? Remember that anything that you put forward as following from a rule within a subproof is not accessible once that subproof ends. But stuff that occurs before the subproof is accessible within the subproofs. So if we could do those non-subproof rules, we should do them now. But we can't. Why? The main connective in each of these is a conditional. The only way that we can eliminate a conditional is with the conditional elimination rule, which requires us to have a conditional and its antecedent. We don't have the antecedent of any of these conditionals in the premises. So we're going to have to start with subproof rules. How do you know where to start? If you have to start with subproof rules, you look at the conclusion. So what we need to demonstrate is a conditional and a conditional. So a conditional with A as its antecedent, and then its consequent needs to be a conditional with B as its antecedent. And the consequent here is a negation. So that's going to actually end up giving us three main subproofs. You'll see there's a few extras along the way. So again, this is going to be quite a complex proof to show you how many layers you may end up with. And this is on the more complicated end of what you'll see, but it's worth making sure that you understand how this works. So line 4 here will be an assumption for conditional proof. So I need to be able to get this conditional with A as its antecedent. So I want to assume A for conditional introduction. Right, so I need to introduce this conditional with A as its antecedent. Note that you might find this whole proof example more useful once you're already a little more familiar with some of the basic rules. And then I need to mark off that this is an assumption. So I have to do a little fancy Microsoft Word alignment here. By making this assumption, now again, what drove it was I need this to be the antecedent of a conditional. But by making this assumption, I should notice, aha, that's an antecedent of one of my conditionals. And remember, get out those rules that don't require subproofs or sub-subproofs as soon as you can. So at this point, I need to move on to line 5 and introduce if B, then C. And that follows from conditional elimination using lines 1 and 4, where the antecedent appeared. Now there's no other rules I can apply, so I have to move on to something else. The goal of introducing this A here as an assumption was to get the conditional proof. What's the goal of a conditional proof? Well, I need to get if B, then not F as my consequent. Since that's a conditional, I'm going to need another conditional introduction rule here. And at this point, I'm going to move my assumptions over because our subproofs are going to have to be moved over. So here I'm going to assume B. And again, this is an assumption for conditional introduction. I'm just going to flag that I may occasionally misspeak and not notice and call it conditional introduction, conditional proof. It's called that in some versions of this system. And again, we need our subproof marker. So the point of this vertical line is to tell us, first, it marks this initial assumption, and it also tells us that we cannot access stuff along this line once we move back out again. So these lines are a really important visual reminder of the boundaries of our subproofs. Now, if I look at this, is there anything I can conclude if I assume B? Well, not from our initial premises, there isn't, but I had this conditional, if B, then C. So again, we have another conditional introduction here. Excuse me, conditional elimination here. So that is from lines 5 and 7. So I eliminate this conditional because I have the antecedent in line, that's line 6. So now at this point I can't add anything else once I've concluded C on its own. So my best bet is I want to further my progress towards the conclusion. I need to figure out how am I going to get not F as the consequent of my conditional here. Well, if I see not F, I'm going to need a rule for introducing a negation. What does my negation introduction rule require? It requires another subproof. So be prepared to add new lines, and we're going to move over. So to get the negation of F, we have to assume F. And this is going to be an assumption for negation introduction. And again, I need to mark that this is an assumption with a new vertical line. And look, if I assume F, something follows from that, from my third assumption. So again, I'm going to move these over. What follows from assuming F? Not D and E. So that's by conditional elimination, lines 3 and 8. Now, what do we do when we assume something for negation introduction? Well, to introduce not F, when I assume F, I need to generate a contradiction. It's not really obvious, maybe, how to generate a contradiction. But presumably, since I've got D and E here somewhere, and then there's an E as a consequent of this conditional, it seems likely that I'm either going to get D and not D, or E and not E, or possibly both, and that those will generate my contradiction. If you've done the last 2 example problems from chapter 16, and if you haven't yet, you might take a look at them now, you'll know that there are 2 sentences that follow from this. D follows from this sentence, and not E follows from this sentence. The challenge is, of course, that the only way we can prove that is with more subproofs. So, as I said, this argument gets complicated. So I'm going to just mark off to the side here and highlight it. 2 goals. I want D, and that will allow me to get E. And then I also know that not E follows from this. So that will be helpful because that will get me a contradiction. So this is just a side note. So I'm going to start by assuming not D and seeing if I can get D out of this, because that will give me E, because I can combine C and D. So you have to kind of look at your assumptions. What do I need to move forward with these assumptions? And then what can I maybe get out of these sentences? And sometimes these proofs are going to require trial and error. You might try something, realize that it's a dead end, and have to start over. So here I'm going to assume not D. And I'm going to do that. I want to get D, so this is going to be an assumption for indirect proof. Now I can't get anything from assuming not D on its own, but there's a funny little trick that's perfectly legitimate. You can do this. Assume D. And this is going to be an assumption for conditional introduction. Why am I doing this? I want to see if I can get if D then E, because then that allows me to prove another contradiction. And if I can prove a contradiction under F, so if I get D then E and not D then E, then I can get not F. So that's my assumption for conditional proof. Sorry, for conditional introduction. 12. That gives me a contradiction. Negation, elimination, lines 10 and 11. That allows me, within the scope of this particular subproof, to add any sentence that I'd like. So I'm going to add E. And that is explosion from line 12. And that allows me to assume this conditional. If D, then E. Let me put those parentheses in because I think it'll visually help. Why does this make sense, this little proof here from lines 10 to 13? Think about this. Whenever the antecedent of a conditional is false, the conditional is true. So if I've already proved not D, then D then E is true. Because if not D is true, D is false. And since D is false, D then E is true, no matter what E is. That's what we learned about how the conditional works. That's our line 14, and that is from conditional introduction lines 11 to 13. And then this means that I have a contradiction here. So that is negation elimination, lines 9 and 14. So notice that line 9 is the negation of line 14. And since what was the start of this proof? And it was an assumption for indirect proof, and indirect proof can end when we get a contradiction. So that means that this proof, this subproof has ended. It's closed. So line 16 can be, we have the assumption for indirect proof. We assume not D, so we can infer D. So that's indirect proof, lines 10 to 15. Oops. Now, since I proved D, that means I can get C and D. So that's from, and that note that that stays within this subproof. So C and D comes from lines 7, that's conjunction introduction, lines 7 and 16. So remember, I can access sentences outside this subproof if they come before it, but once this subproof is closed, I can't access anything in it. But this is a totally legitimate use of this rule. And C and D allows me from my first assumption to infer E. So that's conditional elimination, lines 2 and 17. So if I have E, I know E is true. That tells me that I can get if D then E, simply by assuming D. Why is that? Because once I know that the consequent of a conditional is true, think back to our truth tables that characterize the conditional. Whenever the consequent is true, the whole conditional is true, regardless of whether the antecedent is true or false. So I can introduce any antecedent as long as I know that E is true, I can get the conditional. So the next step is going to be a reiteration of E from line 18. And that allows me to get a conditional proof of if D then E. Just have to say that this closes up this short little conditional proof. So I get if D then E. And that's from conditional introduction, lines 19 to 20. And that contradicts line 9. So I've got a contradiction. We can introduce a contradiction by negation, elimination, lines 9 and 21. And that was my goal all along. I was looking for an assumption for negation introduction. To introduce a negation, I have to get a contradiction. I finally did under the same line as F. So this is within that subproof at the same level. That allows me to introduce not F outside of the subproof. So that was by negation, introduction, and that was lines 8 to 22. Well, not F was the consequent of this conditional I wanted. So I can close off this. That was the conditional I was looking for. So in line 24, I can introduce if B, then not F. So that was by conditional introduction lines 6 to 23. See, these subproofs get a little long. And then line 25, that was the consequent of the conditional I was originally looking for my conclusion. So I can get if A, then B, then F. And that was by conditional introduction, lines 4 to 24. And now I've reached my conclusion. And that's what the whole proof looks like.